In this video, I'm just going to show you some examples of logarithmic equations and how we're going to solve them. So this first one, we have 1 log on the left-hand side and we have 2 logs on the right-hand side, and this looks pretty complicated. We've got one thing over here, this negative, that's might be a little bit confusing for some of us. We also have 1/3 in front of the second log. So first thing, I just want to show you, if I rewrite the right-hand side with the second log first, I no longer really can think of that as a negative log, but I'm thinking of it as subtraction of 2 logs. And when I look at it that way and I see subtraction of 2 logs, I know that we have a property that goes along with that, the quotient property. So I'm going to be able to use that to condense that into just 1 log. But before I do that, I have to get rid of this multiplying by 1/3 for log base 3 of 64. And to do that, I'm going to take 1/3 and I'm going to put it back inside the log as an exponent because I have a property that says that that's okay. So I'm going to have log base 3 of y equals log base 3 of 64 to the 1/3 power minus log base 3 of 16. And from here I've got a couple different options for what to do next. What I think I would like to do next is think about if I can simplify 64 to the 1/3 power. And if you remember, raising something to the 1/3 power is the same thing as taking the cube root. So if I shrink this and kind of move it over, I'll have some thought space over here. So I'm really thinking about the cube root of 64, and the cube root of 64 is 4. So I can really rewrite this as log base 3 of y equals log base 3 of just a plain 4, again because the cube root of 64 is 4, minus log base 3 of 16. Then I'm going to use that quotient property that I mentioned to condense the right-hand side into just 1 log. And what that's going to look like, remember if I have the quotient property, if I have subtraction in the middle, I can rewrite it as the quotient of the 2 inputs for the logs, as long as they have the same base, and they do have the same base of 3. So next what I'm going to do is undo the log. If I have log base 3 of y and log base 3 of 4/16, there are lots of different ways to think about it. The way we've been thinking about it in class is just making that into an exponent with both sides having a base of 3, and then using the inverse property to get y by itself. We get y equals 4/16, and we know that 4/16 is just 1/4, so that would be our answer here. The only other thing I want to double check is to make sure that that's really a solution. It's a positive number, and if I go back and look at my logs in the original equation up here, if I put in a positive 1/4, I don't have anything that would cause a problem with the domain, so it's a real solution. Okay, for this next one, I have 2 logs on one side and just a plain number 1 on the other side. And I've got addition on the left-hand side with the 2 logs. So this one, I'm going to use the product property because I have that addition. And the product property tells me that I can multiply the 2 inputs for the logs together like this. And when I do, this whole thing becomes the input for the single log that I have. To simplify this, if I make it smaller here, have some space, if I want to simplify, I'm thinking about multiplying n minus 3 times n plus 4. That's going to give me n squared, 4n, negative 3n, and negative 12. So what I really have is log base 8 of n squared plus n minus 12 equals 1. Next thing I'm going to do is think about undoing the log. And again, I'm going to undo the log by making a base of 8 on both sides. I'm choosing 8 because that's the base of the log that I have given to me. That's going to create the inverse property on the left where the log cancels out. And I have n squared plus n minus 12 equals 8. This is a quadratic, and if you remember with quadratics, I need to move everything to one side before I can solve. So I'm going to subtract 8 from both sides. That's going to give me n squared plus n minus 20 equals 0. And now I'm going to spend about 20 seconds trying to find these magic numbers. If I can't find them in 20 seconds, that's when I'm going to move on to a different method to solve. I need it to multiply together to give me negative 20 and add up to positive 1. And in 20 seconds I can come up with the numbers 5 and negative 4 here that work with the x box. If I fill this in here, I have n squared, 5n, negative 4n, and negative 20. And if I factor here, I'm going to get n minus 4 times n plus 5 equals 0. When I solve that, I get n equals 4 and n equals negative 5 as my two solutions. And then again, I just need to go up and make sure that neither one of these causes a problem with the domain. So if I look up at my original question up here, I'm going to consider first n minus 3. So if I substitute in a 4 into n minus 3, 4 minus 3 is a positive 1. Positive numbers are okay inside the log, so that one is okay there. And if I substitute into the second one, 4 plus 4 is also going to be a positive number. That's okay. So I know that 4 is a solution. If I substitute negative 5 in here, if I put negative 5 minus 3, I get negative 8. And the inside of a log absolutely has to be positive in order for us to get a solution. So I can eliminate this from my answers, and I'm just going to have one solution even though it looks like two. This last example just starts with a whole bunch of stuff on the left-hand side and a plain 0 on the right-hand side. So I'm going to work on getting the log by itself because I can't undo the log until it's by itself on one side of the equation. So first I'm going to add 6 to both sides, so I'll have log 3 times the log of base 5 of x squared plus 9. When I add 6 to both sides, that's going to give me equals 6. And then I'm going to want to divide by 3 to get the log completely by itself before I do anything else. 6 divided by 3 is 2. So I'm looking at log base 5 of x squared plus 9 equals 2. At this point I can undo the log, so I'm going to make a base of 5 on both sides. I'm choosing a base of 5 because that's the base of my log. And that gives me the inverse property, so I can mark that out. And I have x squared plus 9 equals 25. When I look at x squared plus 9 equals 25, I can work on, this is again a quadratic, I can do this a couple different ways. I'm going to choose to move everything to the left and make it equal to 0 because I want to review a factoring little trick with you. So I'm going to subtract 25 from both sides. 9 minus 25 is negative 16. So I get x squared minus 16. From here, I notice that I have difference of squares. I have a perfect square here, I have a perfect square here, and I have subtraction in the middle. So that tells me that this is a perfect squares problem. I can then factor and make this x plus 4 and x minus 4 equals 0. And that's going to give me two solutions, negative 4 and positive 4. And then I need to just go back and check to see if these are okay in my original equation up here. So if I substitute in a negative 4 squared is positive 16. Positive 16 plus 9 is positive 25. And remember, we're just checking to make sure that the inside part of this log here is a positive number. We're okay there. If I substitute a 4 in, 4 squared is still positive 16. 16 plus 9 is still 25. It's still positive. So in this case, we do have two solutions that are real solutions, nothing's extraneous or faking us out. So we can box our answer and be done.